Welcome to our mathematics lesson, and today we are going to look at multiply fractions. As we saw earlier on in our previous lessons, we've seen addition and subtractions of both the decimals and fractions, but this time round I want us to look at multiplication of fractions. In this lesson we shall look at multiplication of proper fractions, improper fractions, and mixed numerals, both of them put together. Now, what do we understand when we look at multiplication of fractions? That is, for example, where we have a third multiplied by 2 over 3. How do we approach such? Now, you find that, as we said earlier on, that a fraction is simply part of a whole. So if we can have a whole like this, if this rectangular strip means a whole, then if we want to have a third of it, it will mean that we divide it by first 3. This one, each one of it is a third. And when we shed 2 boxes, then it will be from here to here is 2 thirds. That is 2 over 3. So now, but what we need is a third multiplied by 2 thirds. A third multiplied by 2 thirds. Now let us look at this. We have shaded and shown one part of 2 thirds. Now, when we talk of a third of 2 thirds, then you realize that we are looking at a third of 2 thirds. You'll notice that this one box, its 2 thirds is this 2. And this other box, its 2 thirds is this 2. So when you multiply a third of 2 thirds and you want to multiply, you will have this one and this one here. We'll end up getting, the shaded part is what is given. This is a third of one of the thirds, and then a third of another third, so we have got a third of the 2 thirds. And then we count the whole. So total number of boxes is what makes our denominator, 9. And this area that we have shaded now, which is 2, gives us the numerator. So we will define this when you are multiplying. We shall multiply the numerator alone, the denominator alone, which gives us 2 over 9, as we can see here. There are many other ways we can use to illustrate this particular problem, but basically we should know that fractions are mostly used when we are multiplying, and when multiplying fractions, as we shall see, there are steps to observe. We shall look at them independently and see that we multiply the numerators and multiply the denominators without any problem. I want us to look at a clock. All of us know what a clock is. It has got hours ranging from 1 hour to 12 hours to make a day, and also 12 hours to make a night. So when you look at a clock and you want to relate the clock and a fraction and see if it makes sense, we know that 1 hour is equivalent to 60 minutes. So if you are asked for a half of 1 hour, then it will be equivalent as to saying a half of 60, and we replace off with multiplication. So it is a half times 60, you realize that you get 30 minutes. So when you multiply a whole with a fraction, then you'll find that it brings another, it reduces that whole into a certain fraction of a certain value. So we can look at a few examples about time and fractions and see. This is when we have a half of 1 hour. How about a half of 4 hours? Not 40, but 4 hours. So if we want to find a half of 4 hours, we should first be able to know how many hours are there how many hours are there in 4 hours. You know it is definitely 4. So we say a half of 4, which gives us 2 hours. 2 over 3 of 4 hours. Two over 3 of 4 hours. This one will be the same as 2 over 3 multiplied by 4 hours. And you should be able to get how many hours it is. When you multiply these across, you will get it is simply 8 over 3, which is equivalent to 2 hours and 2 over 3. So we have this in hours, but represented as a mixed numeral. So what are we trying to say? We can apply fractions when you are dealing with so many things. But now let us see the steps and the facts to consider when multiplying fractions. First, we note that when multiplying fractions, we say that fractions do not need to have the same denominator. To be multiplied. So for fraction, it's not like addition or subtraction where the denominator has to be made the same, but we can multiply any fraction without caring about the denominator. So we say that for fractions, we do not need to have the same denominator to be multiplied. We don't need. So if we multiply this, so numerator 1 times 1 is 1, and 3 times 5 is 15. So we don't need the denominator to be the same. Also, to multiply fractions, multiply the numerators together and the denominators together. multiply the numerators together and the denominators together. For example, if we have A over B multiplied by C over D, this one will be simply going to give us A times C over B times D. So we don't look at it in a different way. We just need to multiply the numerators directly, and the denominators also are multiplied directly. Next fact to note is that if possible, simplify or divide or sometimes we say cancel fractions before multiplying. For example, we have to simplify or divide or cancel the fractions before multiplying. Now, this cancelling can be done vertically or diagonally. Cancelling can never horizontally. So we shall require, if possible, to simplify or divide or cancel fractions before multiplying. And as we do this, it can be done vertically or diagonally, but never ever do it horizontally. Let's look at an example here. Can illustrate using this here. 3 over 5 multiplied by 4 over 8. Now, here, 4 and 8 has got some common elements or a common factor, which is the highest common factor here is 4. So, by 4 here is 1, by 4 here is 2. And then you move ahead, and 3 times 1 is 3 over 5 times 2 is 10. Here, we have cancelled vertically. This one is vertical cancellation. For horizontal diagonal cancelling, take for example 3 over 5 multiplied by 4 over 6. For this one here, vertical, it can be done, but we find that we have got the highest common factor diagonally. So by 3 here, 1, by 3 here is 2, and by 2 further is 1, by 2 further here is 2. So 1 times 2 is 2, and 5 times 1 is 5. Take note that we cancelled this diagonally. We cancelled it diagonally before summarizing it with a vertical cancellation. So we have seen two areas where we have cancelled vertically as well as horizontally, diagonally. Now, but there's a statement here, cancelling can never be done horizontally. Let us look at what we should never do. (3 over 5) multiplied by 6/7. Now, when a learner decides to cancel by 3 here, 1 by 3 here is 2. This one is cancelling horizontally. And as we can see here, never, cancelling can never be done horizontally. So this is wrong. We cannot cancel like that. Next fact to note, besides simplifying the fractions, for a whole number can be written as a fraction with a denominator as 1. If you are to multiply, for example, we were seeing the other time, a half of 4. 4 is a whole number. So this time round we are saying for a whole number, it can be written as a fraction by simply bringing in a denominator of 1. So for this case, it will be a half multiplied by 4/1. So we have written 4 as a fraction, but its denominator is 1. Now, the next fact to note, the word of, or you can say times, or sometimes we call it lots of, or product, or products. All of these refer to the same mathematical operation of multiplying of x times lots of and product. You come across that, it simply refers to multiplying. Next point to note, for mixed numerals, must be into improper fractions before multiplying. For mixed numerals must be changed into improper fractions before multiplying. What they are trying to say there is that a number like 2.5 multiplied by 1.25, see, we cannot multiply straight away. We must change all of them into improper fraction. That is 1 times 2. This is equivalent to 5/2 multiplied by 5/4. So you can multiply. This is mixed numeral. And this one here is improper fraction. Take note that we have not changed anything. We've only simply written the mixed numeral as improper fraction. That's why we are saying for mixed numerals must be changed into improper fractions before we do the multiplication. And the final point to note about multiplying fraction, is that final answers must always be written in the simplest form. Final answers must always be written in the simplest form. So as we go through the work today, take note of those points that we've gone through, and those are the points we're going to apply. But final answers must be always in the simplest form. So let us start by looking at questions that touches on finding a simple fraction of a quantity. Finding a simple fraction of a quantity, and the question here says find a 2/3 of 15 bananas. So we shall tackle each independently and then we move on to the other. So we want to find 2/3 of 15 bananas. Now for us to approach this question first, let us reduce it and find out how many bananas makes a third of it. So we first have to separate this. We shall, in our solution, we need to identify how about a third of the 15 bananas. And then from here we multiply by 2. So we shall have reduced and gotten 1/3 of just the bunch of bananas, and then we look at it. How about if these were 2/3? Now we have got 15 bananas. These 15 bananas, if we are to group them in the groups so that we have a third, then we find that we shall group the bananas in groups of 5. Taking for example, those are my bananas. So we shall go groups of 5. So you realize for the groups of 5, it makes a total of 15, but each group of 5 makes a third. So a third of 15 is this one stack. If we are to look for the 2 of the 15, we shall look for the second stack. So this one gives us the case that a third of 15 is the same as 1/3 multiplied by 15 into bracket times 2. By 3 here 1, by 3 here 5. Then you have 5 multiplied by 2, you get 10. So we are getting 10 here, and in our demonstration we had 15 bananas. We group them into 5 each, and we have got 2 groups because it is 2/3. If you count, you'll get a total of 10 bananas. Second question. Find B 3/10 of 50 lollies. 3/10 of 50 lollies. So we first again need to know, if we were doing it practically, we put together 50 lollies and we need to divide it in groups of 10. You'll find each lolly will go with 5, 5, 5, 5. So in this particular case, in our solution now, we don't need to do it practically, we can do it mathematically. We find that this is the same as a tenth of 50 lollies, and then we shall multiply by 3. So we want 3/10. So a tenth is how many lollies? Then we multiply by 3. This is the same as 1/10 multiplied by 50, and then finally we multiply the answer by 3. Here 10 is divisible, so by 10 is 1, by 10 is 5. So our answer becomes 15 lollies. So we are able to get the number of lollies we get in case we are asked to find 3/10 of 50 lollies. That is it when you are finding a simple fraction of quantity. Let us look at multiplying proper fractions. We are multiplying proper fraction. Take note that all the fractions we have are proper fractions. So the question A asks us, find 2 over 3 times 1 over 5. In our solution, two over 3 multiplied by 1 over 5. We look at it, if there is any horizontal or vertically where we can cancel anywhere, we cancel, but if not, we simply multiply the numerator 2 times 1, which gives us 2, and the denominator 3 times 5, which gives us 15. So we settle at our answer as 15 over 2 over 15. And why 2 over 15 is because we multiply the numerator together, multiply the denominator together, and our answer is already in the simplest form. So we leave our answer at that point. For the second question in our solution here, it is 3 over 4 multiplied by 8 over 9. Look at it vertically, look at it horizontally, and see, is there anywhere we have a common factor that we can divide? You'll notice that 4 and 8 has got common factors, so the highest common factor being 4. So by 4 is 1, by 4 is 2. This one by 3, we are doing it diagonally. By 3 here is 1, by 3 here is 3. Now we are ready to multiply, so we shall take 1 times 2, you get 2, and denominator 1 times 3, you get 3. So you find that our answer is 2 over 3, and it is in its simplest form. Let us realize that in this question, we first had to cancel diagonally, and we cancel 3 and 9, and also 4 and 8. Now, this question we were given straight times. You will meet a question still on proper fractions, but this time instead of saying times, we have the word of. For example, 4 over 8 of 4 over 8 of 3 over 6. As we saw earlier on in our facts, is that anytime we come across the word of, it simply means multiplying. So in our solution, we shall have 4 over 8 multiplied by 3 over 6. Look at common factors between horizontally, and you'll find that we have some numbers to be cancelled. So we go by 4 is 1, by 4 is 2, by 3 is 1, by 3 is 2. So when you multiply across, you find that your answer becomes 1, and 2 times 2 is 4. So we find that this particular question required us to multiply, and when you multiply and cancel, you get a quarter. So 4 over 8 of 6 over 3 is equals to a quarter. Now we want to look at multiplying proper fractions by whole numbers. Multiplying proper fractions by whole numbers. Let us see. Find A, 1 over 3 times 21, and B, we have 2 over 3 of 32. 2 over 5, not 3, but 2 over 5 of 32. In our solution from the first one, Remember, we are dealing now with proper fractions and whole numbers, so we shall have a third multiplied by 21. Simplify where possible. 3 is a common factor. By 3 here 1, and by 3 here is 7. So you find your answer is a whole number, which is 7. We said we can have this one over 1, which doesn't change anything. So 1 over 3 times 21 over 1, which is just 21. When you simplify, you find that your answer is 7. So take note that a whole number can be written as a fraction by introducing the denominator of 1. So let us look at the other. In this case, again, we have a whole number, we have a proper fraction, but don't have a time sign, but instead we are saying 2 over 5 of 32. As we said earlier on, the word of simply means multiplication. So this is the same as 2 over 5 times 32. Now looking at this, there's nowhere we can cancel, and if we want to make this one a whole number, so 32 over 1, we cannot simplify anywhere, which means we multiply the numerators, then multiply the denominators. And when you do that, you will get this is 64 over 5. That is 64 over 5. 64 over 5 is simply a mixed, an improper fraction, and it needs to be simplified further and be written as a mixed numeral. So this one will give us, it is equivalent to 12, which gives us 60 and 4 over 5. 12 and 4 over 5. That is what we get in this particular case. Remember, we are looking at multiplying proper fractions by whole numbers. We should be able to handle it that way. Now let us come to an area where now this time we shall have improper fractions being multiplied. Multiplying improper fractions. Question, find. We have 5 over 3 times 7 over 2, and B, we have 8 over 5 times 15 over 4. So these are all pairs of improper fractions. So when we are working out, don't convert into mixed numerals or don't interchange anything. Let them remain the way they are, and we start working out. So in our solution, we should be able to identify if the factors are existing so that we cancel. If they are not, we just to go ahead and multiply. So 5 over 3 multiplied by 7 over 2. This one, there is nowhere to simplify, there is nowhere to cancel or divide. So we go ahead and multiply 5 times 7 over 3 times 2. This one will give us 35 over 6. And you can write it as a mixed numeral, which gives us 5 and, because it gives us 5 and 5 over 6. This is simplest form. So in this particular case, the answer is simply straightforward. 5 and 5 over 6. We did this because there was no any number that had a common factor. And then we get the improper, but we don't leave the answer in improper, simplify it further, and get the mixed numeral. For the second part here, our solution, we shall look at it from the major point of view. This is 8 over 5 times 15 over 4. what you have here, we need to identify, are they having any common elements or common factors that we can cancel? Yes. 8 and 4, we can simply cancel 8 and 4. And 8 and 4 we shall have by 4 is 1, by 4 is 2, by 5 is 1, by 5 is 3. So what are we getting here? The denominators are now all 1, and the numerator is 2 times 3, which is 6. 6 divided by 1 is 6. So we find that when you multiply 8 over 5 times 15 over 4, the answer is 6, where 6 is the whole number. Note that we cancelled first before we carried out our multiplication. Let us look now at the final area when multiplying fractions, where this time now we are going to look at mixed numerals. Mixed numerals. So, multiplying mixed numerals. Question, find 2 1/3 times 1 and 2 over 5, and B 6 1/4 times 2 and 2 over 5. 2 and 2 over 5. In our solution, these numbers are mixed numerals, and as we saw earlier on, we cannot multiply mixed numerals until we convert them into improper. So the first thing we do here is to convert the 2 1/3 times 1 and 2 over 5, we convert into improper fractions. And to convert this, it is 3 times 2, which is 6. 6 plus 1 is 7 over 3. 7 over 3 times, now 5 times 1 is 5, plus 2 is another 7 over 5. Take note that the numerator are the same, but we cannot cancel horizontally. So we just go ahead and multiply now the numerators. 7 times 7 is 49, and 3 times the 5 is 15. You are getting 49 over 15, which is the same as 3 and 4 over 15. 3 and 4 over 15. So as we have seen in the first question, let us look at which approach do we give in the second question. We have 6 1/4 times 2 and 2 over 5. Now, as we saw earlier on, the first approach, we convert all the mixed numeral into improper fraction. So 4 times 6 is 24, plus 1 is 25. So we have 25 over 4 multiplied by 4. 2 times 5 is 10, plus 2 is 12 over 5. Now, before you move ahead, you realize that from this improper, we can cancel. We can cancel where possible. So when you cancel where possible, you'll find that by 4 is 1, by 4 is 3, by 5 is 1, by 5 is 5. So we multiply the numerators. 5 times 3 is 15, and 1 times 1 is 1. So this one gives us the answer as 15. So we can simply agree and say that 6 1/4 times 2 and 2 over 5 is equals to 15, is equals to 15. We are able to have our answer in the most simplified way. So we find that fractions by themselves, they have got many areas of applications. That's why we started by first looking at fractions of maybe a certain quantity. Then we went ahead to deal with fractions of the fractions independently, whether improper, proper, or mixed numerals. So let us look at further exercises and answer them. Now, in this question, we are required to evaluate and we are evaluating 5 over 10 of 4 over 7. 5 over 10 of 4 over 7. And then we also look at the second one, which is 7.5 times 4 and 2 over 5. 4 and 2 over 5. So we have to evaluate these two questions. Now for the first one, as we look at the solution, they are testing us if we know the meaning of the word of. So as we saw earlier on, of, lots of, times, all of them stands for multiplication. So we shall rewrite this and say 5 over 10 times 4 over 7. Then we look at it. In this particular problem, can we cancel vertically or diagonally? Yes. 5 and 10 has got a highest common factor as 5, so we can simplify by saying by 5 is 1, by 5 is 2. It is not enough because now we have 1 over 2 multiplied by 4 over 7. Still, when you look at it diagonally, we still have common factors that can be simplified further, which is 2. So 2 by 2 is 1, by 2 here is 2. You remain with 1 times 2, which is 2 over 1 times 7, which is 7. Make sure that your answer is in the most simplified answer. So 7 over 2 is our answer. For the second question, we have our question there, 7.5 times 4 and 2 over 5. The first approach we give in a mixed numeral is to convert what we have into improper fraction. So to convert this, as we convert, we shall look at the relationships of 2 times 7, which is 14 plus 1. So the 7.5 will be equivalent to 15 over 2. Then 4 and 2 over 5 will be equivalent to 22 over 5. How did you get 22? It is 5 times 4, which is 20, plus 2, which is 22. There we are. Then the next thing is, look at it and see, is there a place we can simply cancel? If we can cancel, then look at what is common. We realize that 2 diagonally is common, so by 2 is 1, by 2 here is 11. Diagonally 5 is also common. By 5 here is 1, by 5 here is 3. So when you multiply, it is 3 times 11, which is 33 over 1, which is equals to 33. So we have been able to evaluate or to work out the mixed fractions, and finally we have our answer. We finally have our answer. Now, sometimes we may have statement questions. We are going to look at some other question areas where now we have a statement question. So the question reads, at a particular secondary college, two over 5. At a particular secondary college, 2 over 5 of the year 7 students are boys. Question A. What fraction of the year 7 students are girls? And B, we are saying if there are 120 year 7 students, how many boys and girls are there? Now, this is an application questions where we shall apply our fractions and be able to find the number of girls, be able to find the fraction represented by girls, as well as the number of boys in a class of year 7 students. Now, let us look at the first question. The first question says, at a particular secondary school college, 2 over 5 of your 7 students are boys. What would be the number of the fraction that represents girls? That is, what fraction of the year 7 students are girls? If boys are 2 over 5, then for girls will be the whole, which is 5 over 5, which represents 1, minus 2 over 5, which will give us 3 over 5. Why are we saying 3 over 5? Because we only have 2 gender. We only have you are either a boy in that class or you are either a girl. So we do not have the third alternative so that we can start assigning a fraction. So because there are only 2 options, so the one for boys, we shall subtract it from the one for the total class. And the total class represents a whole, which is 5 over 5 minus 2 over 5, which gives us 3 over 5. Second part of the question says, if there are 120 year 7 students, how many boys and how many girls are there? Simple. We find that for girls, we have 3 over 5. And for boys, we have 2 over 5. That is what we have. So what happens? If the total, we find that the total is 120 students in that class, then it's very simple for us to get now the value that we require for both girls and the boys. Let's see how we shall approach it now here, up here. So to get the total number of boys will be 2 over 5 of the total number of students there in that class, which is 120. Of means multiplication, so it is 2 over 5 times 120. We can simply introduce a denominator of 1 to make 120 a fraction, and then we simplify where possible. By 5 here is 1, by 5 here is simply 24. So when you multiply 2 times 24, you'll get 48. 48. So there are 48 boys. For girls, we have 3. For girls, we have 3 over 5 of 120. 3 over 5 of 120 is the same as 3 over 5 times 120 over 1. By 5 is 1, by 5 here is 24. When you multiply 24 by that, you'll find that this gives us 72 girls. So we have been able to find the number of girls in this particular class as well as the number of boys. However, the total number should always give us 120. We can prove by simply adding 48 plus 72. What should we get? 8 plus 2 is 10, carry 1. 4 plus 7 is 11, plus 1 is 12. So it agrees. So the total number of both boys and girls in that class is 120, where boys are 48 and girls are 72. Can also look at one more question. To paint one classroom, two and a third liters of paint are required. Two and a third liters of paint are required. How many liters of paint are required to paint 5 identical So we are saying to paint one classroom requires 2 1/3 liters of paint. To paint one classroom, 2 1/3 liters of paint are required. How many liters of paint are required to paint 5 such identical classrooms? So this one, we find that one classroom requires 2 1/3 liters. For 5 classroom, it will mean each classroom will be taking 2 1/3, but we have got how many classes? We have got 5 classes. So it will mean that we shall require 2 1/3 liters multiplied by 5 classrooms. And in this case, it will mean that it is, we change it to improper, that is 2 times 3 is 6 plus 1 is 7 over 3 multiplied by 5 over 1. This one will give us, there's nowhere to simplify, so this one will give us 35 over 3. 7 times 5 is 35, and 3 times 1 is simply 3. So from 35 over 3, it's an improper fraction, so we simplify it further. And when you simplify it, you'll find that this is the same as we have 11. It is the same as 11 and 2 over 3. 11 and 2 over 3. But this answer is supposed to be in liters. So in this question then, we are trying to say that for us to paint 5 classrooms which are identical and each classroom requires 2 1/3 liters of paint, then we shall require 11 2/3 liters of paint to paint 5 such classrooms. So with that question, it brings us to the end of our lesson today. In our next lesson, we shall now go and engage ourselves in multiplying and dividing decimals. Thank you.